thing that trips up a lot of people in system design interviews, the CAP theorem. You've probably heard of it, but it can be super confusing. So today, we're going to break it down once and for all and make it crystal clear. Plan. We'll start with the absolute basics. What CAP even stands for? Then we'll get into the real-world trade-offs, which is the juicy part. We'll figure out how to choose between consistency and availability, see how that choice shapes your entire design, and then we'll get into some advanced stuff to really make you stand out. Okay, let's dive right in. What is this thing, really? At its heart, the theorem is actually pretty simple. It presents a fundamental choice that you have to make for any distributed system. And let's be real, almost every system you'll design today is a distributed system. Here's the deal. It says you have three things you want: consistency, availability, and partition tolerance. But you can only pick two. You can't have all three at the same time. It's a classic pick two scenario. So what are these three things? First up, we've got consistency. This is pretty straightforward. It just means that whenever someone reads data from your system, they get the absolute most recent, up-to-date version. No stale data, ever. Everyone sees the same thing at the same time. Next is availability. This means your system is always online and ready to respond. Every time a user makes a request, they get a response. It might not be the most up-to-the-millisecond data, but they won't get an error message. The lights are always on. And finally, there's partition tolerance. This one's a big deal. A partition is just a fancy word for a network failure that splits your system in two, like the connection between two data centers going down. Partition tolerance means your system can handle that and keep on chugging along. So you have to pick two. Why is this so critical in an interview? Because this isn't just theory. It forces a massive decision that defines your entire system architecture from the get-go. And here's the kicker. In any modern system that's spread out across the internet, you can't just hope the network will be perfect. It won't be. Routers fail, connections drop. So partition tolerance isn't really a choice. It's a non-negotiable. You have to build for it. And if you have to choose partition tolerance, that simplifies things a whole lot, right? The actual decision you have to make, the very first question you should ask yourself in a system design interview is this: do I prioritize consistency or do I prioritize availability? All right, let's see what this big choice actually looks like in practice. It's one thing to talk about it, another to see it in action. So picture a social media site. It's got servers in the US and in Europe. User A, in the US, updates their profile name. That update hits the US server. But oh no, the network link between the US and Europe breaks before that update can be copied over. Now, user B in Europe tries to look at user A's profile. What should the system do? Well, this is the fork in the road. If you prioritize consistency, you have to return an error to user B. Why? Because the European server can't be sure it has the latest data, and a consistent system would rather fail than serve stale information. But if you prioritize availability, you just return the old name. It's better to show something than an error page, right? And this is exactly why certain systems absolutely have to be consistent. Think about booking a concert ticket or a plane seat. You cannot sell the same seat to two people. That would be a disaster. Same for an inventory system at Amazon or a stock trading platform. In these cases, serving stale data is catastrophic, so you choose consistency. But for most things on the internet, availability is the way to go. Do you really care if you see your friend's old profile picture for a few seconds? Or if a new show on Netflix doesn't appear for everyone at the exact same instant? Probably not. For social feeds, business listings, and content, it's way better for the service to always be up and running, even if the data is a tiny bit behind. Okay, so you've made your choice, but this isn't just a philosophical debate. This decision has a huge, direct impact on the technologies you're going to use. If you go down the consistency path, you're building a system that's all about data integrity. You'll probably use things like distributed transactions to make sure updates happen everywhere at once. This can sometimes mean things are a little slower because the system has to do a lot of coordination to keep everything perfectly in sync. And that choice leads you directly to certain technologies. We're talking about traditional SQL databases like Postgres, which are built for this stuff, or modern marvels like Google Spanner. Even some NoSQL databases like DynamoDB have a special strong consistency mode you can turn on when you absolutely need it. Now, if you pick availability, you're opening up a totally different world of design patterns. You can spread your data across tons of servers all over the globe for super fast reads. You embrace a concept called eventual consistency, which basically means you're okay with data taking a little while to sync up everywhere because you trust it will eventually. And this naturally pushes you towards databases like Cassandra or DynamoDB in its default mode. These tools are masters of being highly available and scalable. They're designed from the ground up to run in multiple regions and survive failures without skipping a beat.
Okay, just knowing the C versus A trade-off is great. But if you really want to show senior-level thinking in an interview, you've got to add some nuance.
Here's a pro move. Explain that a single product can have it both ways. Take Ticketmaster. The act of booking a specific seat has to be perfectly consistent. But just searching for events, that can be highly available, even if the list is a few seconds out of date. Same with Tinder. Matching with someone needs consistency, but just browsing profiles can prioritize availability. And we can go even deeper. It turns out consistency isn't just an on or off switch. The reality is, it's more of a spectrum. At the far end, you have strong consistency. That's the C from the CAP theorem. But there are other, more flexible models. My favorite is read your own rights. This is a fantastic middle ground. It guarantees that when you change your profile picture, you will see the new picture right away, even if it takes a moment for your friends to see it. And at the other end is eventual consistency, the promise that the system will sort itself out over time. Being able to talk about these different flavors shows you really get the practical side of system design. So, the CAP theorem isn't just some abstract theory. It's a practical framework for making one of the most important decisions in system design. It all comes down to a single question. Faced with a network failure, what do you sacrifice? Perfect, up to the nanosecond consistency, or 100% always-on availability? There's no right answer for everything, but understanding the trade-off is what will make your designs great.